All right, this is still section 2.1, but I split it up into this little chunk of problems. Okay, the first style of problems is converting Celsius and Fahrenheit. You might have done this in your science class, maybe in ninth grade physical science. In physics, if you're doing physics, you probably did it in there. Chemistry, maybe. I don't know. Did you do that in chemistry? Okay, and so we're going to do it again. I'll give you a little formula. Now, I carry around a calculator, or even on my phone, I got a little unit conversion on there, right? That's one of the first things I ever downloaded. One of the first apps I downloaded. I don't know why. I think, I don't know, I was working on something. I said, it'd be nice if I had a unit conversion. I'm like, wait a minute, I got this phone. Let's go to the market thing, and then, yep, downloaded a conversion thing. And it converts all kinds of stuff. I mean, you gotta scroll page after page after page to find what you're looking for. But I also have a regular calculator, little TI 36 or something like that, and it's got a button to just punch it in and convert. Okay, but I'm going to show you how they get those numbers. So we're going to use C for Celsius, and let's see, what color do we want? See any favorites?
Sunshine.
Sunshine. Where's that? Up. Orange. Sunshine. Okay, we'll do sunshine. All right, appropriate for all the sun out today. All right, so here we go. Here's the unit conversions. So Celsius. So this is, if you have a temperature in Fahrenheit and you want to figure out what it is in Celsius, this is what you would do. You would take 5 times the Fahrenheit temperature minus 32, and then divide that by 9. Now, if you wanted to if you didn't have a calculator on you and you just wanted to kind of get an approximation, it's not exact, but it's an approximation, 5/9 is kind of close to what? Who's got a calculator with them? Who's got a calculator? Put 5 divided by 9. 5/9 is what? Okay, say 0.56, okay? So 5/9 is really close to something that we can easily work with. What's this close to that we can easily work with? Okay, 0.5, isn't it? Okay, so 5/9 is kind of close to 5/10, isn't it? Ninths, tenths, I mean, you know, it's close. Not exactly, I understand that. But it's close to 0.5. So watch. If you wanted to just, you're on the street, right? And, you know, you get somebody from basically any other country in the whole entire world except for us. But if they tell you, you know, you say, you know, do you know what the temperature is today? And they give it, actually it'd be the other way around. Let's say you're in Europe, okay? And somebody says, oh, well, could you could you tell me what the temperature is? And you're like, well, I know what it is in Fahrenheit, you know, but I don't know what it is in Celsius. So what would you do? Let's say it's a summer day, right? And it's like what? Let's say it's 87 degrees out, Fahrenheit, okay? And you're like, wonder what that is in Celsius. So first thing you do is you subtract 32 from that. You can probably do that in your head, can't you? 87 minus 32 is what? 55, okay? So that's 55, okay? But, and then 5/9 is close to what? It's a half, right? So if I take 55 and take half of it, it'll give you an approximation, kind of close to what it is in Celsius. So what's 55? Well, half of 50 is 25. Half of 45 is like 27, right? So it's around 27, 28 degrees, right? 27.5 degrees. Would you agree? That's what it would be in Celsius. Now that would be an estimate. It wouldn't be exactly, but you could say it's around, what did I say, around 27 degrees. So if somebody asked you, you know, you say it's around 27 right now. So 27 is a pretty warm day, isn't it? Because 87, you know what 87 is, just kind of natural. You know what that means. But if somebody says, oh, it's 27 out. Oh, it's really warm. It's 27. We don't think that, do we? We think, oh, it's 27. It's freezing cold. Of course, after the last few days, 27 is actually pretty warm, okay, considering single digits we've had. All right, but I think we're up to in the low 30s now. We're up to freezing. Yay! It's a heat wave. All right, anyway, so let's just punch some numbers in. Somebody got a calculator with them? So basically, you could write it like this as well. You could go 5/9, and then go F minus 32. It doesn't really make any difference. So let's do that temperature again. Let's go 87 degrees again and see how accurate we actually were with that. So the temperature in Fahrenheit is 87 degrees. We want to find what it is in Celsius. So it's 5 times 87 minus 32, and then divide that by 9. So that's just a matter of throwing that into a calculator. So that's what? 5 times, what did we say was 55, right? Divided by 9. Give me an accurate number on that. So let me do that. 5 times 55. All right, fantastic. So 5 times, what is it? 30.5? Okay. Now we said 27.5, didn't we? So we were off a little bit, but we were in the ballpark though, weren't we? Okay. So that's not too bad. So that's 35 what? Degrees Celsius. Okay. 30.5, sorry. 30.5 degrees Celsius. Make sense? Once you know the formula, doing the problem's not hard at all, is it? Should I make you memorize that formula? No?
Sure.
What if we go the other way? Watch. The other way, we're going to do the complete opposite. So instead of subtracting 32, we're going to add a 32. Instead of multiplying by 5/9, what are we going to do? We're going to multiply by 9/5. Okay? So it's a little bit different, but watch what we have. We've got 9/5 times the Celsius degree, and then you just add a 32. Here's another way. 9/5. What do you think 9/5 is kind of close to? We know 5/9 was close to a half. 9/5 is close to what? Which is 2. So 9/5 is close to 2, right? So let's say somebody says, today's temperature is 13 Celsius, right? And you're like, okay, like talk to one of the Koreans, because all their temperatures are in Celsius, right? And they'll say, oh, it's 13. Not today, they wouldn't, but they say it's 13 degrees. They mean it's 13 Celsius. And you're like, you don't want to act dumb, right? You don't say, well, what's the real temperature? Well, that is a real temperature. It's just a Celsius temperature. Okay, but what if you wanted to figure that out in your head, and you just didn't want to admit to them? So what do? 9/5. Can you do 9/5 in your head very easily? I can't, but you can. 9/5 you can do in your head? Get out. So 9/5 is pretty close to what? 2. So what do? Double it, right? Which is what? 26, and then do what to it? Add a 32. So you don't just double it, but you double it and add a 32, which is 58. So that's around 58 degrees what? Fahrenheit. It's around. It's close. It's an approximation when I double it. It won't be exactly that, right? Because we went a little more, didn't we? We went 2 instead of 9/5 is a little less than 10/5. So that's a little bit on the high range, all right? But let's plug the numbers in and see what we actually get. So we get 9/5 times our Celsius degree, which is what? 13. Add a 32, and then plunge those in. Somebody do that for me. Why are you quitting? Just because the bell rang? 9 times 13, come on, 9 times 13 divided by 5 equals plus 32.
55.4.
There you go. 55.4 what? Fahrenheit, right? And there you go. Yeah, Celsius, you go from 0 to 100, right? 0 is freezing, 100 is boiling. Makes sense. Why do you go 32 to, what is it, 212? I mean, that's crazy.
I hate the imperial system.
I didn't quite finish this. We'll finish this tomorrow, okay?